Do you know what this is? Or this? Or how about this? If not, you're in the perfect place because that's what I'll be teaching you today. And if you do, well, sit back and enjoy the review. Who knows, you might just learn something new. Hello and welcome back to Coding with Unity. I'm your host Andy, and today we'll be discussing tuples. But we won't be starting with something complicated like I showed before. Let's break it down as simple as we can. So, what is a tuple? A tuple is simply a set of values. So this, or this. Each member field within a tuple is always mutable and public. And because tuples cannot have behaviors but only data, this makes them very lightweight. In other words, a tuple is a simple and more flexible way to write classes and structs. Now that we know what a tuple is, let's create a C# script. Open it up and let's write our first tuple. Above our start method, let's say private string bool my tuple equals hello world true. Then, within the start method, let's type this. If myTuple.item2 is equal to true, print my first tuple says myTuple.item1. Let's go back into Unity and click play and see what happens. You'll see in the console it prints my first tuple says hello world, and if we were to change the true to a false, it would print nothing. I don't know if you're thinking what I am, but it would get pretty confusing having to say item1 and item2 all the way up to however many fields we have declared in our tuple, but luckily we don't have to because C# gives us a few ways to deal with that. Before C#7, to create a tuple, you had to say var item equals tuple.create. And the fields were always accessed with item1, item2, item3, item4, and etc. So, because we didn't provide a field name with our hello world tuple, which is known as initializing with literal constants and is referred to as an unnamed tuple, we also have to access the fields using item1 and item2. But now in C#7, we can use the new feature tuple field name projections to name our fields. To name the fields in our tuple, let's say private string message for world, bool show message to world. Now, doing this gives us a named tuple, and also helps us understand what the values within the tuple actually does. When we go to access the fields, we no longer have to say item1 and item2, we can now use the names of the tuples. So inside of our start method, we can replace item2 with show message to world and item1 with message for world. Clicking play within Unity confirms this still works. But what if we said within our start method, var item equals 1, sword, 32. Using the var keyword made us unable to name the fields in the same place we previously did. So instead, we can specify the name as a part of the tuple initialization by saying var item equals id1, item name sword, and damage 32. Which we can then access with item.id, item.itemName, and item.damage. We also have one more way to name our tuple fields, which is known as tuple projection initializers. And to use this, we would say intx equals 12, inty equals 4, var player position equals parentheses xy, and then we can print out player is at x, player position.x, y, player position.y. Which you could probably guess will say player is at x12, y4. So, at first this may seem pretty straightforward, but what would happen if we just had inty equals 4, player position equals 12y? If you guessed it would be accessed with player position.item1 and player position.y, you'd be correct. But what if we said var toString equals JSON, var item1 equals 15 and var 5 equals 5. Then we'll have another var that says player equals toString item1 and 5. It might be a little harder to guess how you access each of those values, which how you actually would be with player.item1, player.item2, and player.5. But with a little more clarity on how we name things, it will help us to avoid the two conditions where candidate field names are not projected onto the tuple field, which these two conditions are when the candidate name is a reserved tuple name. Examples include item3, toString, or rest, or when the candidate name is a duplicate of another tuple field name, either explicit or implicit. One other thing to keep in mind is if you use a tuple to create another tuple, it will be created as a named tuple using the original tuple's field names. But even though your IDE doesn't suggest it, if you were to still type item1 or item2, your compiler will not throw an error because that would be a breaking change for code written with C# 7.0 or lower. Now that we know how to create a tuple and fully went over how they are named, we can move on to talking about comparing tuples without getting confused on how we access the names of our tuples. With the release of C# 7.3, tuples began supporting equal and not equal. The equality checks works by comparing each member of the left argument to each member of the right argument in the order they are typed within your tuple. When a comparison returns false by not being equal from the left side to the right side, the comparison will short circuit, meaning they will stop evaluating the rest of the fields. The same rules apply for equal and not equal. So, this would return true, and so would this. And we can also use nullable types with our equality checks, meaning this will also return true. And so will this. We can also perform implicit conversions on each member of both tuples, meaning we can compare longs with ints and still have it return true. One last thing to note is nested tuples of the same shape will also return true when compared. A major use for tuples is to be used as return values for your methods. So instead of having to do all of this, having a weapon equals new item, get item current durability, get item max durability, current durability equals get item current durability, max durability gets get item max durability, debug.log weapon durability is current durability max durability, we can just say weapon durability equals get item durability. Debug.log weapon durability is weapon durability.current weapon durability.max. Another useful type of return is the one shown in the beginning of the video, where we used tuples and links to return a list of nothing but the weapons within our item database. And although this may be very clean looking, it's worth mentioning using Linq in a Unity environment can cause unnecessary garbage collection, and it may be better to write it out as a for loop instead. Now, if we want to use the fields within a tuple to perform some code without having to go within the tuple to access the fields, we have three different approaches to deconstruct our tuples. We can either explicitly declare the types of each field in the tuple by saying int current and int max is what our sword durability will be, or we can implicitly declare the typed variables for each field in the tuple with the var keyword, by just saying var current max. An explicit type cannot be used outside the parentheses even if every field within the tuple is the same. We can also use the var keyword inside the parentheses on each field individually or all of them interchangeably. In each of those calls, we will be able to just say durability : current / max. And using the last method, we can simplify a lot of our Unity methods when all they are doing is setting private values with a getComponent call by just saying start will predicate to rigidBody transform animator, which will be equal to getComponent rigidBody transform getComponent animator, which will be taking a set of objects our behavior will be using and making sure none of them are nulled by setting them within our start method. One last thing to point out is tuples can also be used as out parameters. You can do this with named and unnamed tuples. So one very useful thing you can do with a tuple is if you're ever in a job interview and you get asked swap x with y, we can simply just say int x, int y, xy equals yx, which will swap x to be equal to y and y to be equal to 7. Much easier than creating a temp x. So this is all great and dandy, but usually syntax sugar means we're giving up on performance, especially within the Unity environment. So what's the performance look like when we use tuples? Well, if you look here, our garbage collection on 500,000 calls is the exact same with and without using tuples. You may also notice the gc.collect is slower with tuples, but the gc.allocate is faster. And the allocation is usually what will cause lag spikes within your game, but with how small of a difference these numbers are on 500,000 calls, it's really your choice on which one you would rather use. So, with all of this being said, I hope you can find some useful places that tuples can help you with your project. Games quite often find themselves using designs that use data structures that store multiple elements but do not define behaviors, as classes and structs do, so using a tuple in place is easy to do and should be highly considered. You may not want to pass data around your game using a tuple, but for utility methods that are internal within a class, it's a great way to keep you from having to create an entire class or struct just to pass some groups of data around. It's also very useful when your return types have multiple elements, so you don't have to type out multiple methods to return one part of the value that you need. Admittedly, you could have just read the Microsoft documents to learn everything that's in this video, but Microsoft's documents are not catered to game devs using Unity, for the most part. And most Unity users seem not to look into the docs themselves, so I'm trying to merge that gap between the two by making this video. And if you can think of any other uses where tuples can help you in your code, leave a comment below letting me and others know. I'd love to hear from you. But I hope you learned something from this video. If you did, give it a thumbs up and consider subscribing to the channel. If not, you know what to do. But until next time, have a wonderful day and stay coding.